Good day, students. Welcome to mathgotserved.com. In this group, we're going to be going over an introductory tutorial on linear functions. We're going to start out by taking a look at the graph, a linear graph of a function that relates time to the amount of bricks produced at a plant. Okay, so let's go ahead and sketch the following linear function. So we have the x and y axis. This is the x axis and this is the y axis. And in the x axis, we're going to be going by 3. So that's 1, 2, 3, 4. This is in hours. Okay, the time is measured in hours. So in this function, we're looking at the relationship between time and the amount of bricks made by a factory. So in the first hour, 10 bricks are made. In the second hour, 20 bricks are made. In the third hour, 30 bricks are made. And then in the fourth hour, 40 bricks are made. Okay, so let's go ahead and graph the points. So starting from 0, 0 hours, of course, no time has passed, no bricks were made. 1 to 10, 2 to 20, 3 to 30, and 4 to 40. Okay, so this is our linear function right here. Alright, so let me draw it again. Let's just make it a line segment. So we're going to be answering some questions concerning this linear situation that we have here. Alright, so the first question we're going to be looking at is the independent and dependent variables. Alright, so based on this graph that we have here, time in hours, and this is bricks made. Bricks made. Basically, number of bricks made. So the independent variable is what? The independent variable is the variable in the x direction. Okay, so think about time. Time is independent. How do we know time is independent? Because time doesn't depend on anything. Alright, so time is the independent variable. So the independent variable in this problem is the time in hours. Okay, also think about the independent variable as the x-axis. Now that we know the independent variable, what is the dependent variable? The dependent variable is the y-coordinate, the y-axis, which is the number of bricks made. So the number of bricks made is dependent on the amount of time given. Okay? Alright, next thing we need to find here is the domain. What is the domain of this particular function? You want to think about domain as the width or horizontal span of your graph. How wide does this graph span? An easy way to determine that is to project the graph onto the x-axis. What does that mean? Well, imagine that you have a roof right here and you want to cast a shadow. You want to cast a shadow on the floor. So imagine you have a flashlight up top here. What is the shadow going to look like? Alright, let's go ahead and sketch that. So what we have is a situation where this point stays where it's at, doesn't do anything. And then this point right here the rightmost point gets projected straight down like this, and the shadow is cast upon the x-axis. Okay, so the domain is going to start from this point and is going to include everything in between all the way to this point right here. So that is basically your domain. Think about domain as the horizontal span of the graph. So from here all the way to there, that's your domain. All right. So let's write that down. In interval notation, your domain is going to be going from 0 all the way to what? 0 all the way to 4. That's your domain. Now, what's the range? You think about domain as the width of your graph. Think about range as the height. How high can you go and how low can you go? All right, for the domain, we casted the shadow of the graph on the x-axis. For the range, guess what we're going to do? We're going to project or cast a shadow of the graph on the y-axis. All right, so this point stays where it's at. The uppermost point gets projected right there. So from the bottom to top, that's going to be your range. Do you see what the range looks like? Let's go ahead and shade it in. So the range is going to start from 0, and it's going to include everything in between all the way up to 40 right there. That, ladies and gentlemen, is your range. Think about the range as the vertical span of your graph. Okay? So that's the range from top all the way to the bottom. Okay? All right, let's write that down using our interval notation. For the range, we're going to go from the low point, which is 0, all the way to the high point of 40. Alrighty. All right, so there goes the domain and range. Now we want to describe the rate of change here. The rate of change or slope. The rate of change is the same thing as your slope. So is it positive, negative, 0, or undefined? To help you remember, let's recall our mnemonic tool to help us remember that. That is Mr. Slope Guy. Let's go ahead and draw Mr. Slope Guy real quick. So this is the left eye, and then the right eye, negative, and then you have his nose. Let's draw that again. His nose, and then his mouth. So there goes the nose of Mr. Slope Guy, and there goes his mouth. So underneath the nose, you have U, and to the side of his mouth, you have 0 and 0. Okay, so there goes Mr. Slope Guy. So Mr. Slope Guy helps you remember the rate of change. Okay, is it positive, negative, or is it undefined or 0? So we have this line. The line is going up from left to right, just like the left eye of Mr. Slope Guy. So what is the sign of or rate of change of the sign of the slope of a line that's going up from left to right? A line that's going up from left to right has a positive slope. So this line has a positive rate of change. Why? Positive because the function is doing what? The function is increasing from left to right. It's increasing from left to right. All right, how about the last thing we want to find out is the next 2 points. All right, can we follow this pattern and extrapolate to determine what the next 2 points are going to be? Well, let's go ahead and see what we have here. We have 1, 2, 3, 4. So the next point should be 5, comma, a number. And then the next one will be 6, and then a number. All right? So how do you get the output from the inputs? 1 goes to 10, 2 goes to 20, 3 goes to 30. You notice that we can just multiply the inputs by 10 or just add 10 to the outputs to get what the next output is. So for 5, you can add 10 to 40 to get 50, or you just multiply 5 by 10, which gives you 50. And then for 6, you get 60 as the next pair. All right? So that's that. Okay, and then one last thing. Let's describe the graph real quick, okay? And then move on to the next problem. So how will we describe this graph that we have here? So we want to describe it We can describe it as follows. You can say the number of bricks made. Number of bricks made does what? The number of bricks made increases because it's going up, increases by what? Increases by 10 every what? Every hour. Alright, so that's a description of what's happening with this function. It's increasing by 10, the number of bricks made every single hour. Alright, now let's take a look at another example. Now for this one, we're going to be considering the relationship between time in months and the number of houses present in a community. Okay, so at month 0, there are 120 properties in the community. 2 months later, there are 120 properties. 4 months later, 120 properties. 6 months later, 120 properties. Okay, so this is our time in months. And on the y-axis, we're looking at number of houses or properties. Okay, number of houses in a community. All right, let's go ahead and answer some questions concerning this graph right here. All right, we're going to start off by identifying the dependent and independent variables. Okay, so independent first. The independent variable, remember that's always on your x-axis direction. Your independent variable is going to be your time in months. And then what depends on that? Your dependent variable, your y-axis, is going to be the number of houses. Alright. Now let's look at the domain. The domain of the graph is how wide it is. Okay, so we can just project this straight down to the x-axis and look at how wide it goes. Alright, so let's project this down. That goes down there. This goes straight down. And your domain is the set of points from 0 all the way to 6. That's your domain. Okay, so what's your domain for this problem going to be? Your domain is going to be the interval 0 to 6. Now for range, since the function doesn't move up or down, the range is just going to be the value that it attains or retains for the entire time interval, which is 120. Alright, how about a rate of change or slope? The rate of change or slope of this line, we have a horizontal line here. If you go back to Mr. Slope Guy, a horizontal line has a slope of 0. Why? Because the line is horizontal. The line is horizontal. You don't have any rise, you just keep running. Okay? So that results in a 0 slope. Now, let's figure out the next 2 points. Can we determine what the next 2 points are following this pattern? Next 2 points coming up. So we're going 0, 2, 4, 6. It increases by 2, so the next will be 8 and a number. And then after that, will be 10 and a number. Now, you notice that the output remains constant. It's always 120. So what do you expect will happen in 8 months? Same pattern. 120 in 10 months, 120. There goes the next 2 points. Alright, description. Let's describe what's going on with this graph. The number of houses as what? Is constant. As constant. Constant means does not change. Okay? is constantly 120 as time increases. As time increases. Okay? So that is the description for the graph that we have in question number 2. Okay? As time increases. Alright, so that's that. Thanks so much for taking the time to watch this presentation. If you found the contents of this tutorial helpful in your studies of functions, do give us a thumbs up. We really appreciate your positive feedback. If you have questions or comments, do post it in the comment section below. Don't forget to subscribe to our channel for updates to other presentations such as this. More videos, worksheets, games, and tools can be found at math.surf.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.